this is a continuation of the last video. My phone was dead, and I apologize for that. Okay, so we were talking about relating reactions and k-values and talking about if you flip a reaction to the reverse, you take the reciprocal, and talking about if you were to double a reaction, then you square Kc or Kp. If you divide a reaction by 2, you raise it to the 1/2 power or take the square root. Okay, so that's kind of where we were. So now we're going to apply kind of a Hess's law idea that says that we can add reactions together, and then we can manipulate our Kc and Kp value that way. So let's say we had this reaction. So this should still be on the same part of the notes we were on just a minute ago in our last video. And then this. Okay, so let's say that this is my reaction, okay, and then let's say I have a second reaction that looks like this. Okay, so I can write Kc values for both of these. I'm going to scoot the board over for just a second. This one would look like this. Okay, and my second one would look like this. So I don't think that should be new to anybody, based on what we've been doing. And let's say I know this value, I really don't have room there. We'll go up here, 0.014. And this one is 7.2. Okay, we're given that information in this problem. Okay, so what we're going to do now is attempt to add these reactions together. So, and then we'll see what the overlying result is for the K value. So if I were to add these together, just like a Hess's law kind of manipulation, where I'm canceling out things, my BR2s cancel, and that's basically it. So I'd be left with the NOBr plus Cl2 yields 2NO plus 2BrCl. Okay, so if I were to write a Kc expression for this overall reaction, well, first of all, let's back up and talk true Hess's law in thermochem. If I were to add reactions together in thermochem, Hess's law says I can add the reactions together and I can add the delta H values together, okay? But this isn't thermochem. This is equilibrium and Kc, and they're ratios. So here I've added my reaction together, but we're not going to add Kc. It doesn't make sense. So I want you to look at the Kc's for these two reactions. Okay, and then we're going to write the Kc for this reaction, which would be my products. Oops, that's squared over my reactants. Okay. So if you notice, let's go back and assume that. Well, no, I don't want to do that. I'm sorry. Okay, so if I look at my Kc, it doesn't really resemble either of these two things until I inspect it a little bit closer. And if I look very closely, if I notice that this part, okay, is coming from this, and this part is coming from this, you might be questioning, well, what happened to the BR2? Okay, well, what did happen to the BR2? They canceled out, right? They're actually there and they canceled out. So in this case, I would not be oh my gosh, I just gave it away. I would not be adding my Kc values together. I'd be multiplying them together. So Kc overall would be equal to Kc reaction 1 times Kc reaction 2. So numerically, it would be, this, whatever that comes out to be, 0.10 1 or 0.10 technically to 2 sig figs, and so that's my Kc overall. Okay, so if you want, we can do a couple bullet points in the manipulation of Kc or Kp. So, or we can call them takeaways. Okay, so takeaways. If you reverse reaction, you take reciprocal of K. If you multiply a reaction, you raise K to that power. If you divide a reaction, you raise K to 1 over that power. And when you add reactions, you multiply your K values. Okay, so those are your takeaways. Right, there's 2 practice problems on the very last page of this, practice number 1, practice number 2. I'm just going to go ahead and give you the answers and see if you can figure it out. So those are my answers to the practice. If you want to jot them down and then give yourself a second to see if you can solve those. So that is part 2 of manipulating chemical reactions and K values.